All right, everybody. Let's try something a little different. We'll try and do the video like this. See if this helps at all. So, we're talking about well, the parts of the function. And so we're getting into, let's see if I can find it here. So let's move down through the pages. Been through that, been through that, been through that. And we ended up in this wonderful area. We talked about the different asymptotes and how they might not be true asymptotes. If n is less than m, then we're looking at approaching 0. If n is equal to m, then it's going to be the coefficients. We divide the coefficients and we get a over a divided by m, or a divided by b rather. And if n is greater than m, then we have no asymptote that's horizontal. Instead, we end up with a slant asymptote. And we have this cute little guy right there. So, and moving on, we have the next section of notes. The last little section, a vertical asymptote is a line x equals a, where a is a real number, where the function cannot cross. Removable discontinuities are also called holes, or x-intercepts are where the graph crosses the x-axis, and the y-intercepts where it crosses the y-axis. We get into a whole kind of slew of different, okay, I want to do that, but not yet. So let's hop down to, here we go. Okay, well, let's talk about end behavior. So, when talking about end behavior, once again, we're talking about the fringe, not the center of the graph. So, if we have a, we're 5x squared minus x plus 9. This is out of your note section, divided by 2x squared minus 2x plus 4. Here we see that the powers are the same, and so we have a horizontal asymptote at 5 over 2. So when we approach it from the left, or as we're going left, we're going to be approaching 5 halves. As we approach infinity to the right, we're going to be approaching 5 halves. So same thing there. B, I know it's a messed up B, oh well. But B, we can see now that n is less than m, and so our horizontal asymptote is going to be y equals 0. Limit as x approaches negative infinity is 0. Positive infinity is also 0. C is a little bit more different because we have a slant asymptote. So we have an m that's greater than, we have an n that's greater than m, so we have to find the slant asymptote. How do we do that? Well, let's go back to here, and let's take a look at our slant asymptote here. So we take it and we divide. We go through the long division process. We end up with x squared minus x minus 2. That's our slant asymptote. We do end up with a remainder of 3. We don't care about the remainder. All we care about is the actual, what we get before the remainder. So there's your slant asymptote. So we get a slant asymptote of y equals x squared minus x minus 2. So limit of x approaches negative infinity is that. As approaches positive infinity is that. Okay, what does that look like? Well, it looks like, let's go through the process here. If we take a look, start with f of x equals x squared minus x minus 2, we end up with the vertex, if we put it in vertex form, which I like to do, is going to be x minus 1/2 upon a squared minus 9 over 4. That is vertex form. That gives us our h and our k of our slant asymptote. So we take the function y equals x to the third minus 2x squared minus x plus 5 divided by x minus 1. And we see that we have a vertical asymptote at 1. And so we have a domain of negative infinity to 1 and then from 1 to infinity. Graphically speaking, we have this guy. So first thing we see is in blue, I'll illustrate here with my little pencil, we see in blue we have our slant asymptote. We come down to half 9 over 4. I found the points, you factor and solve it, you're going to come up with the points negative 1 and positive 2 are our zeros. So we make our little dotted line and our little dotted line. We have a vertical asymptote here at positive 1. And so now the question becomes, okay, well, where does the function exist within these realms? And that's where over here in purple, we're going to pick points to decide where things go. I picked the point, first thing I found was the y-intercept down here at the bottom, y-intercept down here at the bottom. We plug 0 in for everything, so we get 0 minus 0 minus 0 plus 5, and then 0 minus 1, and then 5 divided by 1 gives you negative 1. I'll move up here so you can see that. You plug in 0, 0 minus 0 minus 0 plus 5 gives you 5. 0 minus 1 gives you negative 1. 5 divided by negative 1 is negative 5. So that's this point down here at negative 5. Boop, boop, boop. Okay? So I know that the left side is going to bend around the slant asymptote. I also went ahead and found the point negative 2. Negative 2 gave me the point positive 3, which is nice. So here's my 2 points. I bent around my asymptote. And I know that up here, same kind of idea. Since I did negative 2, I tried positive 2. Positive 2 gave me a positive 3. So I have my little point here. And then once again, it's going to exist between the 2 asymptotes. So bend up around, bend up around. Once again, this is a sketch, not necessarily an all-out graph. We did graph as much of it as we could, but in the end, we ended up with a sketch. Okay, so that's that. So let's move back into graphing rational functions. So we have examples here. We can see that the x's are the same. So since the x's are the same, my powers are the same. So it's going to be the coefficients, which is just going to be 1 divided by 1. So it's going to approach a horizontal asymptote at 1. Same idea here. We have a vertical asymptote. We set this equal to 0. We find out that x is equal to 4. We have an infinite discontinuity there. We have a y-intercept. You plug in 0. You get 0 minus 2 divided by 0 minus 4 gives you a half. So 0 and then a half. Now, x-intercept. Where does x equal 0? Well, if I'm looking at this trying to make trying to make y equal to 0. I apologize for that. Trying to make y equal 0. Well, how do I make this equal 0? Well, if it's going to be 0 divided by some number, that equals 0. So 2 minus 2 gives me 0 on the numerator, and then whatever the denominator is, as long as it's not also 0, then you have an x-intercept at 2, 0.